Okay, so 2.2, proving lines are parallel. So, converse means backwards. Okay, it just means we're going to undo what we had done before. So we have the converse of corresponding angles theorem. So our corresponding angle theorem last time said if two lines crossed by a transversal, then corresponding angles are congruent. Yes? So now we're going to say it backwards. If two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. Oops. If I could spell right, we'd be on a good roll. Okay, so it's just opposite. Before, if they were parallel, corresponding angles were congruent. Now, if the corresponding angles are congruent, the lines will be parallel. Okay, converse of the alternate interior angles theorem. Well, alternate interior angles were congruent, so now if two lines in a transversal form alternate interior angles that are congruent, then the lines are parallel. So, is it important for you to know what make alternate interior, what make corresponding? Yeah. Yes. Why do you think I told you over and over and over to write those things down?
To help us get in our heads.
Okay, so the converse of same side interior angles. Same side interior angles were supplementary, correct?
Yep.
Okay, so now if two lines in a transversal form same side interior angles that are supplementary, S-U-P-P. Supplementary, then the lines are parallel. Okay, the converse of the alternate exterior angles. Alternate exterior angles were congruent, yes?
Yeah.
So if two lines in a transversal form alternate exterior angles that are congruent, then the lines are parallel. Okay. Okay, so the next one. If two lines are parallel to the same line, then they are parallel to each other. Now stop and think about what that just said. If two lines are parallel to the same line, they're parallel to each other. Well, does that kind of make sense?
Yeah.
Okay, so what I'm saying is if A is parallel to B and B is parallel to C, then A is parallel to C. Okay, now look at your picture. Oh, actually, have you written that yet? This should be A to C. I'm going to have to use the picture. Because it says A and C are parallel, doesn't it? How do I know that? Because of the red arrows? And it says B and C. So A is parallel to B. Because both A and B are parallel to line C, yes? So that means they have to be parallel to each other. This is the transitive property. That we have in algebra. Okay, the next one says, am I going too fast? If two lines in the same plane are perpendicular to the same line, then they are parallel. Okay, well, B and C are both perpendicular, A and B are both perpendicular to C, correct? How do I know they're perpendicular? The square, yes? Well, aren't these corresponding angles?
Yes.
Yeah. So it's using that same thing. So it just says that A is perpendicular to C and B is perpendicular to C, so that means A and B are...
Perpendicular.
No, they're not perpendicular. Parallel. They can't be perpendicular. That'd be impossible, right? Does all that make sense?
The two lines in the parallel line.
Yes. And the perpendicular symbol, we'd say that A is perpendicular to C and B is perpendicular to C, then A is parallel to B. So we got all the definitions done. You'll just need to,
That upside T?
yes, Maya,
Yes.
you'll just have to watch for the examples.
Okay.
So today you're going to be proving to me why things are parallel. Okay? So you're going to be writing the converse of the alternate interior angles theorem, the converse of the corresponding angles theorem, the converse of the alternate exterior angles theorem. Okay? So lots of words today. So, when building a gate, how does Bailey, not Billy, know that the vertical boards V and W are parallel?
We don't have a picture. Because he's smart.
Okay, so you have to draw a picture. If you don't have a picture, you have to draw the picture. So when I draw this picture, it is not going to look like this gate. It is basically going to look like, let's make it simpler. We got 3 boards this way, yes?
Yeah.
You should have a spot right down, you should have a spot like under the 4th one.
Right.
Like basically right where my picture is. Yes, right over there. Oh yeah, I put yours on the side.
Yeah, I'm gonna skip these.
Okay, we'll go back to them. And then we've got a board this way and a board this way. And then we got something like this. Yes? So this is A, B, C. And this board is V. And this board is W. And I have angle 1 and angle 3,
What in the fuck?
angle 2. I got a right angle and I got a right angle. Oh, and I got 35.
What is that? What is that V at the top?
This board,
Going down. V? Oh, it's an arrow.
no, it's just it's a board. This is V, see?
Oh, okay. I was really confused.
Okay, you look at their picture. Don't look at mine, look at their picture and draw your own. Because I'm not going to draw a picture for you. I put my V and the W at the top because I liked it better at the top. Does it matter if I put it at the top or the bottom? Nope. I just need to know that V and W are this big boards right here, right? Okay. I don't have room for the picture because I've got the picture. Okay, when building the gate, how does Bailey know that the vertical boards V and W are parallel?
Because they both have like the because they don't touch. They both have a right angle.
They both have a right angle, yeah. And if the board's here and the board's here, yes. Yes.
Yeah.
And they're both perpendicular to what? A. Okay, so that would mean A was the transversal and these would be the parallel lines if they were parallel, yes? So what are these two right angles to each other? Maybe you should look at your words on the front.
Converse of corresponding.
Those are not corresponding angles.
How am I supposed to know what these pictures are telling me? They're all exactly
It's
the
the
same.
same side interior.
All the pictures are exactly the same.
Yeah, the pictures are the same.
They don't tell me anything.
Well, they shouldn't have been. My pictures weren't.
They're all-
Okay, they are same side interior, yes?
I don't really know
Well,
what they
okay,
are.
we'll go back. But you should know what the words mean without the pictures by now, correct?
I don't.
You should know what the words mean without the pictures. We will go back and fix them. Same side interior.
Supplementary.
Why are these same side interior angles, guys?
Because they're on the same side of the
Same side of the
parallel.
transversal,
I thought they had
interior of the parallel lines. What?
Well, you said same side of the transversal, and I thought they had to be inside the parallel lines, but you said it right after that.
Right. Same side first, then inside. Same side interior. Okay, so it's the converse of the same side interior angles theorem.
Theorem?
Isn't that what it says on the front of your paper?
Yeah, I just didn't know how to spell it, so I was like,
Oh, I thought you were asking a question.
no.
Okay, so that would be your answer. That is your whole answer. So when you go through your assignment today, it should read converse of the same side interior angles theorem. Okay?
Okie dokie.
Okay, Bailey also needs board C to be parallel to board A. What should angle angle 2 measure and why?
Angle 2 or angle? It's the-
So she needs to have
90.
board C be parallel to board A. So I need A and C to be parallel, correct?
Yeah.
Okay. So what should this angle be? Well, what's my transversal to board C and A? I need a transversal.
The V and W, isn't it? The one that's running through the middle.
Well, it could be that, or it could
The
be...
one that's like from the top right to the bottom left.
Right, but you don't have any information about this one. She's saying this. But do I have any information other than the 35?
No.
No. That doesn't relate to 2, does it? What would be a better, Pearl?
The V and W.
The V and W. So let's do the V because V is touching angle 2, isn't it?
Yeah.
Okay. So in order for C and A to be parallel, what does angle 2 have to be?
90.
90. Why?
Because it's a right angle.
Why? What theorem tells me?
I don't know.
Isn't it the same side?
It's the same side interior angles. So the
Make sure to write it on the last one.
converse of the same side interior angles theorem. Works, I guess. Since I put so, which is weird to put so there, but I did. Bless you. Okay, what should angle 1 measure to ensure that board B is parallel to A?
35.
So now we're going to be looking at Jalen, your board that you wanted. We had B and A, right? So I have B and A. So now we're going to be looking at what? This one?
Yeah.
Okay. So what should angle 1 be for those two to be parallel? Yep, for B and A to be parallel, what does angle 1 have to be?
Would it be 35? Since they're
What's parallel mean?
145? Yeah, because would it be 145 or not?
Why?
Stupid. I mean, no, right?
No, why?
Because 35 and 145 equal 80.
Why does angle 1 and 35 have to equal 180 if they're parallel?
So it makes a line.
Because they are what?
Supplementary.
Because they're what location of each other?
Which ones? Same side. Interior.
They're same angle 1 and 35 are same side interior of A and B, aren't they?
Yes.
Okay, so 145, and then again, converse of the same side interior angles there. Okay, so every single one of these were the same reason, but it had a different location, correct?
Yes.
That is why on everything all last week, that is why we spent 4 days last week rather than the one the book told us. You have to find a way to remember those. Okay, the next one is B parallel to C and explain why.
Yeah, because of the transitive rule they told us on our
Because of the transitive rule, yes?
Yeah.
Because we know that first one we said that what? C was parallel to A. So C is parallel to A. And A is parallel to B. Because it's this other one we just did, right?
And if A is parallel to those, then C and B have to be parallel.
So C and B are parallel by the transitive property. So this why question that I've been trying to get you to answer every time you give me an answer is what you're doing today. It's the why. Why do you know it? Now, do you have 5, 6, 7 on your paper? Is that on the top?
Yes.
Okay. Okay. We have 5 and 6 go to the top picture, 7 goes to the bottom picture. If angle A is congruent to angle 1 is congruent to angle 2. So I should put something to say angle 1 is congruent to angle 2. Yes?
Yeah.
Okay, so on your picture, you should be doing that. Because one little swoop says they're congruent. Yes? Which theorem proves that C is parallel to D?
Alternate interior.
What, Jalen?
Alternate interior.
Or alternate interior angles theorem. Or the converse, right? What?
What does converse
the opposite, because before we said if the lines were parallel, then they were congruent. Now we're saying if the angles are congruent, the lines are parallel. So it just means backwards.
Did that say interior?
Yes, my pen is jumpy. There's an INTERIO. Yep, it's all there. Now you guys know what I feel like when I grade your tests. Okay, now it says if angle 2 is 4x minus 6 and angle 3 is 2x plus 18, what are the values of x if A and B are parallel? So it says A is parallel to B, yes? And we're talking about angle 2 and angle 3. What's the relationship between 2 and 3?
They're
Alternate exterior? Or no?
Yeah, alternate exterior.
Well, alternate exterior would be,
Alternate.
yes, they would be, because if I cut off this part of the picture, yes? These would be exterior of the parallel lines, yes? Okay, so we're going to write alternate exterior. And what do we know about alternate exterior angles? They're congruent, right? So what do I need to do with my 4x minus 6 and my 2x plus 18? Set them what? Equal. So 4x minus 6 equals 2x plus 18, and solve for x.
What's the little?
That means congruent.
Are we actually solving for x?
Yep. Did you get 12?
Yes.
Okay. Using the converse of the same side interior angles postulate theorem. I think they're all theorems on the other side, yes? Yep. What equation shows that G is parallel to H? So we need to use the same side interior angles theorem. So we're going G is parallel to H. Yes?
Yeah.
There's too many big words in that. Definition.
So what do we know about the same side interior angles? They're what? They're supplementary. That means they what?
Equal to 180.
Equal to 180. So what are my same side? How many transversals do I have of those parallel lines? I have 2, yes?
Yeah.
We'll call this one L and this one H. Okay? So if I'm talking about line L, what are my same side interior angles?
1 and 3.
1 and 3. So 1 plus 3 equals 180.
Yeah.
If I'm talking about H, what are my same side interior angles?
2 and 4.
So angle 2 plus angle 4 equals 180. Is it okay for me to add extra things? Ooh, I shouldn't have called that one H. Why?
Because there's already an A.
There's already an H. Is it okay for me to add extra things to this picture if it's going to help me?
Yes.
Yes. Okay, so evidently your pictures are not the same. I have to go back and look at that. Maybe when I put them on the bigger paper, I didn't fix them. Okay, your pictures should look like my pictures. So number 1, your corresponding angles should be 1 and 2.
Yeah,
Because if
that
I
one's
slide
not.
that, okay?
Is the next
Okay, so fix it.
and the rest of them are just all the same as the other one.
Okay, so fix them. Okay, so alternate interior. So they should be here and here. What's another set of alternate interior angles? Here and there?
Yeah.
Okay. Again, alternate of what? Alternate of the transversal. So here's my transversal, yes? So on each side, an interior of the two parallel lines. So the next picture, same side interior. I have 1 and 2. Where's another set of same side interior? 3 and the other side, right? So 1 and 2 and 3 and 4.
Oh shoot.
An alternate exterior, or on the alternate side of the transversal on the exterior of the parallel lines. So we have one set. Do we have another set?
Right where the one is on the wrong side.
Yes?
Yes, you don't.
I should have just made you guys draw your own picture. Would have been better, huh?
I took it now.
What?
She's actually done one.
Okay.